Good afternoon, good morning, folks, wherever you are in Canada. My name is Chris Ballard. I'm the CEO of Passive House Canada, and I'm really delighted today to bring you the second in our northern climate building for passive houses. We pulled this together with the help of Parks Canada, and we'll get the show on the road. Feel free to leave questions in our chat and we'll answer them either as we go along or towards the end. But let's get the show on the road. I will share my screen. Let me do that. You get a beautiful view of my desktop for a moment until I fire up our slide deck. So there we are. So once again, Chris Ballard, Passive House Canada, and welcome to our second cold climate webinar in our 5-part series brought to you by Passive House Canada and Parks Canada. Today we're going to be looking at the Valleyview Town Hall. It presents a vision for sustainable growth and a cornerstone for the community. Valleyview had a vision of becoming a leader in environmental responsibility, and with a skilled design and construction team, including Flechas Architecture and Scott Construction, this building is aiming to become the first Passive House certified commercial building in Alberta and the first Passive House Plus commercial building in the world. So in today's session, we're going to be chatting with Oscar Flechas of Flechas Architecture and with Cliff Huber from Scott Builders about the collaborative process involved with the design and construction of a passive house building and the valuable lessons that they learned, because these are lessons that we think that anyone who is interested in working with Parks Canada in the Nipigon region would be wise to pay attention to. In collaboration with Parks Canada, this session is geared to inform the design community, contractors, engineers, tradespeople on how to meet design and building standards for new builds seeking to achieve Passive House certification. So our agenda today, we've had our introductions. We're going to get an update from Parks Canada on the Lake Superior National Marine Conservation Area. Then Passive House Canada will talk a little bit about the need for high performance buildings. Then we'll look at the Valleyview Town Hall, the case study. We'll have a closing, and then we'll have some questions and answers. So without further ado, I will be clicking the slide button. So panelists, just let me know when you want to move to the next slide. But without further ado, I want to turn the proceedings over to Garth Grunerud, Asset Manager of Northern Ontario Field Unit for Parks Canada. And Garth is going to update us on the planned administrative building and discovery center for the Lake Superior National Marine Conservation Area. So over to you, Garth.
Right on. Thanks very much, Chris. It's a pleasure to be here for our second. And yes, as Chris mentioned, I'm the asset manager. I'm a mechanical engineer as well for Parks Canada, and I deal with our business unit in Northern Ontario. So as Chris mentioned, this and the name of this is quite a mouthful. It's Lake Superior National Marine Conservation Area, Discovery Center and Administrative Building. We have to find an acronym for that. That works for everybody, but as for right now, we'll just say that. We can move to the next slide, Chris. So I'm here to provide another status update on our Lake Superior NMCA building. Today, I'd like to speak about one of the areas of our building that required additional consideration and coordination, and that's our gallery and interpretive area. It is our understanding that there are not a lot of passive house buildings in the world that have gallery and administrative areas that are very energy intensive or require a lot of electricity for moving displays, visual displays, audio. So that's one of the items that we had to work with our consultant and our internal team on. So it's been a pretty active communication with our passive house certifier and our internal team to make sure we're moving in the right direction. And as of today, I believe we're in design, past design development. We're into detailed design with the actual, for the tender docs for this project. So moving on to the next slide, please. So the interpretive area for this building, or for our building, will take up approximately 20% of the building floor area. And through analysis, it's expected to consume about 25% of the overall building energy. And that's for lighting, interactive technology, and displays. So it's quite significant when you're looking at putting a great number of the energy into one room of this building. The image below shows an early concept. So very much a museum or gallery area where we'll have interactive displays, people will be able to walk to. It can hold somewhere between 30 and 35 people comfortably. That'll be able to walk around and move around and see what Lake Superior and the National Marine Conservation Area has to offer. Through the Passive House analysis, we continue to meet our targets of Passive House Plus. We've been in the range of that. That's what our consultant is telling us. And we've been moving up and down a little bit, but predominantly that's the number that we've got and are maintaining. So the question is, how did we get here? So if we can move to the next slide, Chris. So we've had regular meetings with our consultant. A lot of communication and project meetings have helped, and a lot of them have been very positive. And there are a lot of meetings with both Parks Canada staff and with our two consultants, one for the interpretive aspects of the building and another for the building. We've also had an opportunity to meet with our team to look at space, what was needed and what was wanted. We've had to work with them to understand their needs and wants. And this has led to the interactive space being rotated north of the building, which in earlier concepts, it was facing south. So we've limited the amount of windows that we've needed for that space to work with our consultant for interpretive. And it's worked out great so far. And other aspects we've had to do is optimize egress doors and look at display equipment selection. So I'm new to this as far as speccing and looking at display equipment. And there's a whole range, same as building a passive house wall. You can build it from pre-manufactured assemblies, or you can select equipment from bits and pieces and make your own assembly for display equipment. And we've had to look at that and look at optimizing all of that equipment to help bring the energy costs down for the operation of those displays. So it's been quite an endeavor, and it's been moving well so far. And most importantly, we've had engagement from all of our staff, Parks Canada staff and our two consultants, and we've all been working towards the same goal, which is to have an exceptional visitor experience standpoint of this building and to have a very low energy consumption for this building overall. So rather than putting visitor experience on a pedestal above energy performance or energy performance and sacrificing visitor experience, our whole project team has had buy-in on this project. So it's been very beneficial, and hopefully in the next few months, we'll have a tender package ready, and that'll be moving forward to solicitation. So thank you very much, Chris. I'll pass it back to you.
There we are. Yes, thanks, Garth, for that. We're here to learn from those who've gone before, so that when you put that tender package forward, I think folks will know more about what to expect. A little bit about Passive House Canada. We're a membership-based social enterprise. We do a lot of advocacy work, education, and professional development. We provide technical services for members, and we have members and staff and instructors located all across Canada. Our goal is to make zero-emission buildings known and adopted by government, industry, and the public, to support government and industry in the transition to high-performance buildings through education, certification, and policy development, and to promote the Passive House Institute building standard. So that's some of the things we do. Moving right along, the question is, well, why do we need high performance buildings? We hear that quite frequently. Quite frankly, here's the key driver. It's GHG emissions, greenhouse gas emissions from buildings across Canada. And frankly, together we're not doing a wonderfully great job at dropping that curve. We've sort of flattened the curve over the past few years, but we all know that we need to do more. So how do we do that? How do we reduce GHG emissions from buildings? We know that in Canada, if we look at space heating alone, kilowatt hours per square meter, residential buildings on average are about 121. Commercial buildings are up over 203. We have to drop that by 88 to 93% to get to our Paris Accord commitments that federal and provincial governments have signed on to. And we see that one of the best ways to get there is by adopting a passive house building standard. And you can see it uses passive houses down there in that little red block, 15 kilowatt hours per square meter per year of energy. And so a lot of governments are adopting that type of standard to get their buildings to low energy usage. And as I said, a lot of governments are adopting that. Back in 2016, the Pan-Canadian Framework on Clean Growth and Climate Change was signed by the provincial governments, territorial governments, and the federal government. And number one on their list was adopting increasingly stringent model building codes starting in 2020. That code's going to come out towards the end of 2021, we now know. And to adopt a net zero energy ready model building code by 2030. So change is not only on the way, it's also here. Very simply, what is a passive house? Well, the basic concept is really quite simple. You keep heat in during the cold months and you keep heat out during the hot months while continuously improving indoor air quality. Passive house buildings come in all shapes and sizes. Here's 4 examples from Canada, but we've got lots more. And Canada really is becoming a leader in large buildings built to the passive house standard and doing some really unique things. So here's a sample of 4 buildings. Our website has many, many more pictures and data. So moving along, there are 5 principles of passive house, and you'll learn all about them coming up. We have buildings that are super insulated, that are airtight construction, that are thermal bridge free, that have high quality windows with solar orientation, and that have really good ventilation systems. If you're going to have an airtight building, you better make sure it's got a good ventilation system with heat recovery. But here's one that we like to add, and this is why we're delighted to be working with Parks Canada in the early days. It's all about massing. It starts with the design of the building. You can't take an off-the-shelf design and easily turn it into a passive house building. So we know that we'll hear more about the collaborative work that needs to be done to build a passive house building down the road. So why do you build to the passive house standard? Well, we talked about greenhouse gas emission reduction early on, but passive house started off as a comfort standard. It's a healthy indoor air quality. It's also a health standard. You get a durable building. You get, obviously, a highly energy efficient building. You get your greenhouse gas emission reductions, and there are cost savings both upfront and long term. Now, one of my favorite slides, this is the Saskatchewan Conservation House in Regina, funded by the federal government and Saskatchewan government back in 1977. So the standards that we're talking about today, the passive house standards we're talking about today, really have a lot of their roots, a lot of their DNA in Canada. This building was built using the most current building science of the day: super insulation, good quality windows, ventilation. Those 5 principles I talked about earlier, they were all incorporated into this early passive house type building that the Saskatchewan government and Canadian government put together. This building was studied as part of the development of today's modern passive house building standards. So a lot of what we're talking about today started right here in Canada, and we should be proud about that. But moving ahead, what I want to do is introduce our keynote speakers today. We have Oscar Flechas. He's the principal of Flechas Architecture, and Oscar's going to be the presenter. He has with him Cliff Huber and some others from Scott Builders. They're going to be standing by to take your questions at the end. And it's great to have Cliff and his team here. Great to have Oscar here. Oscar, I will turn the microphone over to you, and I am here to click the slides as you see fit. Thanks for being here today, Oscar.
Okay, thank you very much, Chris. Thank you, everyone. Sorry. So let's start pretty quickly. I don't have a lot of time just to tell you all about the project, but I will try to go over the key points really for what it means to be to have this type of buildings on a cold climate. So I think that the important issues here will be a little bit of explanation related to the procurement process for this particular building, how all the principles really apply, and I'm not going to go into much detail. It's what happens or what will be different in our cold climate example. I will have probably my closing remarks and bunch of questions. Yes, I think that I will probably run the presentation, but the team from Scott Builders is here. So we have Cliff Huber, that is the business development manager for Scott Builders. We also have Michael Dornbus, that he was the project manager for the project, and we have Rob Ashley, that he was the superintendent. So a lot of the questions probably will go for them, because it's important also to know that we not only think about this building, but we make them a reality somehow, and more in a, like in this case, in a cold climate and remote location. So next. So the procurement process, next. This project is a little bit different than a regular. As many of you know, the typical construction or bidding process go design, bid, build type of thing. This one is a design, bid, design, build type of project. Notice the word design twice on my thing. It was done some indicative design at the beginning. The owner, the municipality decided to go with a team of an architect and mechanical engineer and an electrical engineer just to guide them to the process. First of the functional stuff of the building, but second is like if they wanted to achieve this type of building, an RFQ and an RFP went out just asking for those particular requirements that they were part of the passive house. So the goal was really to do that selection of the design build in order probably just to minimize the risk that sometimes expose making these buildings, because it's not the norm. So next. So now I will explain a little bit of what this building was. It's an 800 square meter building, 2-story plus basement, and includes really offices, meeting rooms. It's just the administrative office. And it was a requirement, and I will confuse things here a little bit, but there was a goal of achieving passive house, and there was, of course, the thing about achieving passive house international or passive house US. The benefit it was that it was not comparing apples to apples. They put a weight system on an RFP so that if you were achieving PHI, you were given a few more points than if you were achieving PHI US. So that's always been a discussion. I'm right now working on a project in Edmonton. Probably we're gonna go bias on this one, but it's something just very interesting in terms of what is real or what is valid or what is getting into the problem of just a number and a name, but in reality is the value of passive house all around. So next. So this is the big thing. Oh, probably this one is kind of a little bit of animation, Chris. So if you can click again. So we have here the team really, and it was Scott Builders as a design build. I was there kind of second, but I have all the others on this team because it's so important to have everyone on board. And in this particular case, I have to say, even the landscape architect is important for this type of projects. We need to know where it that we're planting trees and all that. The civil engineer, the structural engineer is your friend all the time here for cold climate. So having the right team, it was really important. And all of that, Marken and ECA in Germany were also helping us just to achieve what we needed. Next. So a little bit what they were looking, the town, is the lowest price, but they had a waiting system. So next. The way that we did it and the proposal is that we said we're gonna go through Passive House Classic. That was the intent at the beginning, and it was PHI. And what we did, it was we had this indicative design, but to make it work, we need to implement some slight changes. That's probably where the work comes in, how you make these things still affordable. So we had to change this thing a little bit. Next. So things like where are we going to put mechanicals, and hard to read on that is a slide, but it's moving things slightly. Again, they have gone through a big process of just making sure that this building is what they wanted from the functional point. We just did small changes just to be sure that we were making it work from the functionality of the passive house. Next. And a lot of work went, even going back kind of to the preliminary design again, and start playing with window sizing, orientation, shading, all of that, just to be sure that we were gaining every kilowatt. That's something that happens on cold climate. For my friends I used to practice in Vancouver, so I have a lot of friends doing that in Vancouver. So it's a lot easier just to do it over there than when we try to do it just on cold climate. So we need to play a lot just to get every single kilowatt on this one. Next. So this is probably important because we're the motivation from the town. So it was initially minimize the life cycle cost of this building, a conservation first approach with a focus on occupant comfort. All the passive house was because it was kind of a lifetime investment for them. So I'm putting money where things don't move, in the walls, insulation, things like that, good windows, and just doing the little on the mechanical side. The building is also kind of adaptable and flexible for a lifespan of 75 years. So even when we were doing the request for proposals, we needed to show them how this building can grow, if it grows or something like that, and that we can just not having to demolish this building in 5 years or 10 years because the requirements are a little bit different. And originally was a net zero ready building, and it was done just because they thought that it was needed to be more for that location, resilient to changes in climate, technology, or energy. The building ended up being, as I'll probably tell you later, a passive house plus, because also we got money just to put a little bit solar. So it changed a little bit. So next. So we'll go through the principles right now and see what happened on this building in particular. Next. For some of you that don't know about a Valleyview, it's kind of an hour from Grand Prairie, an hour east from Grand Prairie, 3 hours west from Edmonton. Next. And this is the building, the way that we look right now, finished. Next. And next, this is the photo that I like. This is during construction, and this is really the photo that I like. I think that probably this one is taken when the temperature is at -35 or something like that on a site visit. So this is really what is completely different on this type of buildings, and that's what is very important to see, that it can be done. It's not easy, but it can be achieved. So next. The benefit on this one is that the town has the ability just kind of to find an ideal site. That not always will happen. And in this case, we had a little bit of a park that is in front of the south face of the building. Most of the orientation is then facing south to the park and all that. So that's a plus. And that was something even at the site selection time that it was important to do. Next. So the 5 principles here: insulation, airtightness, thermal breach free, windows and doors, and mechanical ventilation. So let's see what happened here in insulation. Next. 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 This one is a little graphic that I have with the comparison with Alberta Building Code, National Energy Code, and what happened to this particular building. And again, we went in areas, even on the roof, like 100 compared with the 4159 that is required by code. So in many areas, we go almost twice as much insulation as required. And next. I did this for Enercan, I believe, a few years back. And it was, what is the meaning of the envelope or the requirement of passive house and the opaque envelope? If you see the requirements for cold is around R47. And we have values that are a little bit more. Why? Because it's a balancing act. And in this case, if I will have been able to use a certified ERB, cold climate windows, and a little bit more of extra air tightness, for example, that roof will have dropped from the 100 to 50. So all of that needs to be taken into account. And the benefit right now for many of you is that we're changing dramatically in terms of technology, and more things are available right now to make these buildings even easier. Next. Details. Nothing new there. It's extremely important, and more in this cold climate, just to be sure that you had it right. Next. Airtightness. That's number 2. The same thing, probably by code is there like 3.2, 2.5 air changes. Right now, passive house is 0.6. Next. The strategy on this particular building was tape OSB, and that's what you see here. And again, that's what we did it for this building, and it was mainly based also on the fact that it was a remote location, and it's like, how can we just do things at that area that are still kind of simple, and that it could guarantee us that we were going to be certified. Going back to the RFP, that was in the documents. We needed to achieve certification. So otherwise we will be penalized if we would, Scott Builders will be penalized if we wouldn't achieve that. So this one was a strategy simply just to be sure that we were achieving that. But again, the same thing, you can do it many other ways. So next. This is kind of the mid-construction blower door test, and this is kind of the big moment on a passive house construction project, I believe. If you see, this is positive, negative, but we are on the 0.36, 0.37, down from the 0.6. So this one is a big reassurance for the construction team that you're doing something right. So I believe for Scott Builders, what this moment that is like, we have probably have been put all the effort just to make it right, but now we're gonna be tested And at this point, when they achieve this one, it's kind of saying like, oh, we're doing it right. So that's important. Next. And as you see, it's a lot of tape for the OSB strategy. So next. Thermal bridge free. This is again next. When I said my structural engineer is the friend, nothing in the code other than effective insulation and things like that. But in reality, for us, is and in cold climates, is extremely important that you don't have as many thermal bridges. Next. And this is what it is. Nothing really penetrates the building. Everything stays outside. The structure is just a decoration. Next. And in this particular case, the building is fully wrapped with continuous exterior insulation. This is the Gatrix that is imported, sadly, because we have too many. That's also what we need to help the industry to change, because we have the material, the raw material to make these buildings here. So it's not only a transformation on us as designers or the engineer or something like that. We need the industry also to change a little bit, because we can do this locally much better. Next. So you see, this is kind of the two images. Is technically a box. That's what we did, the simplicity on the form as well. And then you see that later on is when we put in kind of the decoration, the little overhangs and things like that. But in general, that's the way that we achieve this thing here on thermal bridging. So next. And this is the roofers probably testing that decoration of the building still is has support. All the structure as well is outside the envelope. Nothing is penetrating. Next. Windows and doors, that's the next one. So we didn't have, as I mentioned before, the really good windows. National Building Code still is in the R3, R2, and we need windows that are R8. And even though we don't have passive house cold climate window when we were doing this project. So next. We end up using Eurolines, I believe, yes, triple paint and all that. And we made it work really just because we were able just to provide kind of heating at each of the locations of the building, just because we were lucky, as I said, facing almost south of in all our building phase. Next. And again, for window, same details, also just to be sure that you're doing it right. Next. And for this particular project, we use expanding tapes just for window installation. Next. And regular interior tapes and exterior insulation. Next. So probably we will talk about a few of the nightmares that happen here, but technically I can just mention one here for windows and doors, and it was that requirement of a commercial door, that it was not existent. You have to import. I think that right now you can get those, but it was the same. It was, if you were getting the ADA seal, you couldn't get the card reader. There was no automatic operator. There's no guarantee. You poke a hole on the frame, things like that. So that was escalates to price, outsourcing the piece of equipment becomes a little bit of a challenge. Probably the contractor has much to do about that. And it's like the same, what is it affects your timing in construction and all that. Next. Mechanical ventilation, that's next. Nothing really on building code at the same level of passive house. And on this one, what we did, it was a Tempest unit that was made in Canada, but of course it doesn't have a PHI or a certification, so you get a little bit of penalized by the unit, but something that again we still have very good equipment that even though it doesn't have the certification, we probably can use. In this particular case, I believe that Zwigon came in later with the certified unit, and I think that it was they came to my office probably 4 weeks before we ordered this unit. So it was like, okay, nothing that we can do. But that's also a demonstration that technology is changing, and we need to embrace that even for cold climate more and more. Be kind of at the top of what is available out there and what is that is really high quality. Next. To make it work for cold climate, we had to do a little bit of a trick to have the heat pumps working. They are on a separate room that get tempered at minus 15. So because that was the problem, these things kind of died at minus 20, and that's the problem that goes with cold climate. So next. So we have to do this in a separate room that a regular electric heater just condition that little space every time that it comes at minus 20. And that's the way that the building continues operating. Not as energy efficient, but it's not that it happens all the time. It's just when the temperature is a few days minus 20, but for a location like this, it's not crazy just to see that the temperature sometimes stays minus 40 for a week or something like that. So it's not that the building starts operating, it's that it doesn't operate all that efficiently, and that's it. Next. So closing remarks from my end. Next. The first thing that you need is leadership, and I'm glad to see here Parks Canada, and because that's what happens. It's like in this case was the town of Valleyview. It was council saying we want this type of building, and knowing that there is a little bit of risk involved, knowing that you need to minimize that risk, knowing that there's still a few unknowns. We need to do it. We need to start kind of taking that step just to make sure that we're going on the right direction. And we need everyone, like in this case, Passive House Canada, or everyone that is in the industry to learn from each other. That's what I'm saying. I always joke about these presentations because I do this one kind of in the positive note that everything is good, but I would like to do one on the things that don't work, or that the screw ups and all that, because that's also the learning process on all this, because it's not perfect science as well. We are still just doing this to do that. So being a leader from the person that is making the investment is so important these days to make more of these buildings happen and make them even better and right down the road. Next. So this one ended up being a passive house plus a little bit by accident. The government, the provincial government was giving money for installation of solar. So although we, at the beginning, we were hoping just to have classes, when we said, now that we have this grant for solar, what happened if we put solar right here? And essentially it's like pretty easy, was jump to be a passive house plus. It was, we were hoping to be a first one. We were not. We ended up being in the first one in North America. And still, of course, we were kind of the first one in Canada to this level of performance. Next. And this is where we are. So we're a little bit even past the plus. We're getting almost at the premium. Next. So for some of you that are familiar with the certifications, so Classic, Plus, and Premium, I think that you can click next, Chris. This one probably has an animation too. Oh, yeah, that's the previous one, sorry. Correct. So this one in the plus really is that we have something a little bit close to net zero. And but I also have the other two right there, the energy feed, because the retrofits, I think that are so important, and they will be something really important for cold climate. And I have also the low energy building. And I have to say right now in my buildings, and that was going back to the discussion of PHI, FIOS, all of that. Right now, some of my buildings, as I said, I'm doing one that is probably going to be filed, but I'm doing other two that are on the low energy building standard. And I have one that is, I'm designing in format that is also to that level, because it really makes more sense. And that's what I have. Dr. Feist there, I was probably in Vienna or something in one of the conference, and we just bumped into one of the coffee breaks, and he said like, hey, the typical introduction, where are you from? Blah, blah, blah. I'm from Canada, anything exciting? And I said, yeah, I'm doing something in Alberta, from Canada, up north. And the guy even said like, oh, you know that we have the new low energy building. And I said, yeah, I know, but the building that we're going to doing is going to be a passive house plot. So it was like, really? So sometimes you need to just balance what it makes sense, because it comes with a price tag. So it's important also just to know what is the level of performance that you need to achieve on cold climate to get it at a price point that as well is important and is affordable. So that's my take on certification. Next. So the additional cost of this building and the savings, technically, is what I did is, and don't take me on an economics course here. It was very simple in terms of comparing this as a regular office in Alberta, the passive house, and what was the reduction, and what was the savings really on gas. And so it's almost 79%. Next. The way that we did the math on this one is it was also pretty easy. It was, what is that these guys pay for electricity? We put a number right there. And then we decided, okay, now let's plug the same numbers to the new building. Next. And when we have these numbers and we plug it at this point, it was when the cost of carbon was $30. And if you put it just as a simple payback, we were looking at 18 years for the passive and 17 with the solar. Next. But because we were in Alberta, we didn't like a carbon tax. So when we remove that, we just have to spend a couple of years on that payback. And you see the number right now on the passive house, a regular building will cost you 18,000 to operate. The same building now is 4,000, and I have to say those 4,200. I saw the number recently, and that they pay is pretty close to that amount, and that amount is the account of really for the administrative cost of being tied to the power. So that's kind of, you have to pay that money one way or another, because you're giving them some energy in the summer, taking it in the winter. So that's the thing. But at this point, it's like, and those of you that like math, think about this one when the cost is 170, because then that number will reduce dramatically, probably to the 4 to 5 years or something. So for many buildings in cold climate, will make a lot of sense to have this. Next. And I finished my presentation with this one. It's like each building that is allowed to be constructed at suboptimal efficiency is a 50+ year liability in a world that needs to be almost decarbonized in the next 30 years. So I think that we need to act now. So that's for me. Next, I think that's the end. Correct.
Good.
So thank you.
Thank you.
Open the floor for questions.
Great. Thanks, Oscar. And I know we've had a lot of questions coming in on the chat. I'm going to turn the questions over to Sarah from Passive House Canada, who's been monitoring the chat, and just get her to read the questions out. So either yourself or Cliff or a member of his team can answer them. But looks like we've got some good questions.
Hi, everyone. Thank you, Chris. So the chat has been incredibly active. So there has been a lot of discussion back and forth. So I'm just going through what we can here. One of the first questions that we had was, and I'd like to ask the panel, how was thermal bridging of the overhang supports managed?
They wanted me to answer that one, for example? Yeah.
That'd be great.
Okay, that one is like all the exterior really is like, it's kind of double attachment. So we will go with one that attached to the building, and the second structure attached to that one in a different location.
Okay, great. Thank you. Another question that's come in was, how was domestic hot water generated?
Domestic hot water is a heat pump, domestic hot water tank.
Okay. Another question was relating to insulation. What insulation material did you use for the walls?
The walls are regular Roxol. We have a 2x10 wall, really, that is Roxol. We have an internal wall 2x6 that is also Roxol, and the exterior goes on 1.5 inches, I believe, of Gutex.
Okay, great. There's another question here from Shelby. It says, for summer shading, what have been the ideal strategies? For example, fixed overhangs, movable shading devices, or exterior roller shades?
Good question on that one. With heat pumps, the benefit is that you get a little bit of the heating cooling. You still have to be careful of not overheating this building. This building, the demand on cooling is almost zero. I think it's 0.2 or something like that. And we did the shading, not because of the overheating or something like that. It was just for glare.
Okay, thanks, Oscar. I think a few more questions here. Is it still cost effective to spec a full electrical backup system? Have you considered a ground source heat pump?
Yeah, that would be, and that's ideal, but it's more expensive.
Okay, sounds good. Let's see here. I think this is actually the last question here. Was there a certain level of training needed for trades on some of the products related to higher efficiency?
I'm glad that now we're moving to the contractor side. Yeah, go ahead, whoever wants, because there's, I think, if you don't have many, I will have more questions for the construction crew.
Yeah, I can answer that one. Like, we worked with our trades in this project. It was difficult at the beginning, but our super on site, Rob, had to watch the trades very diligently. So we looked after all the taping ourselves, which took a lot of the risk of the project. But framing, we worked with the framer very well. The mechanical contractor, there's somebody we worked with before, and we had the trades buy into the program. So the trades weren't allowed to cut any holes in the building without our approval. We had signs all around the building stating that. So we had to cut the holes, we had to seal them. And that took out a lot of the risk in the project for that.
Great. No, thank you for answering that one. We have another question actually that came in. What is the feedback from occupants and as well as for comfort? Can any of you speak to that?
Yeah, I can talk about it. Because people is not asking about the challenges here. So we had a little bit of a challenge studying the building when I got a phone from the mayor saying, Oscar, this building is not working. And they're like, what? So part of the problem was that this trick that we have to do on the exterior room to make it work during the winter. So the building was operating, but the electrical bill was a little bit higher. So it seems that someone came readjust the dial on the temperature, not going to minus 15, but it was still the plus 15, and the ceiling was something, a little bit of damage on the road. So we have to go review that, fix it, and all that. The building right now is working kind of at the level that it should. But of course, at some point, that is what probably tell us is commission is important, educating people is important. And for this type of buildings, it's important to consider that comfort is not the same for everyone. I've been there in the middle of summer when one level of the building is at 20 degrees and the other level of the building is at 18 degrees, for example. So because someone wants the building a little bit cooler, someone wants to be heated. And that is very something that happens on these type of buildings where you have multiple occupancies on offices, because it's the same. The level of comfort is not the same for everyone. So they like it. Sadly, we also were hit with COVID. So occupancy of the building has been reduced, the operation of the building. So that impacts. We relied on those things for energy. So it's still kind of, we're learning all the time of what happens, how people use it and all that. So it's still something interesting in that end.
I see. Okay, no, that's great. Thank you. I think we've probably got time for just a few more questions. So I'm going to just go to a few more here from Scott. What was the sequence to install the exterior walls?
So basically, we had to build a box first. So we built that outside box with the OSB. It was all taped off, sealed, and then we had put the second floor in. So then we had those interior chase walls built underneath that second floor. Rob, you have anything to add?
You're talking about the sequence of how we did the exterior walls?
Yeah, exterior to the interior.
Yeah, we did the 2x10 first. Then obviously we insulated from the outside, and then threw the Gutex on, and then did our OSB from the inside. Once we've done our air seal and then we had the windows installed, and we did our blower door test, we knew that everything was fine. Then we framed up our 2x6 wall, and then that would basically give everybody for their mechanical and electrical to run through that wall. Once we knew that was good, then we insulated that and drywalled the finish.
Okay, great. So here's another question. Are you doing any energy monitoring or wall durability assessments?
Yeah, sadly, no. We put that on the initial idea of getting it costs some money and you need someone to monitor. And it was sadly, the end of the day, they said, no, we're not gonna do it. It will be something of those things that it will be great just to get a grant, just to complete the monitoring of this building.
I see. Okay. Okay. I think we just have probably time for maybe one more question here. So let's see here. Are there any lessons you learned that you wish you knew at the beginning?
We'll leave that to the builders.
Yeah, the lesson learned would be product availability, product selection. For instance, I think Rob would prefer not using the Gutex, and now there's other products available. As Oscar mentioned too, we had some problems with the doors, like the operators and what's required by code for, operators, door strikes and other security requirements you have. So that was definitely a lesson learned, is that was not readily available. And having the right trades, there's one or two that we probably would prefer not having, but that was, you got to have the right people doing the work.
Right.
When you're doing a blower door test in your final, make sure you have water in your traps and toilets.
Yep.
Okay. I was asked just to ask one more question as well. This is the final question. How did you attach the OSB wood inside the house, since each nail to hold them can create a hole? Did you tape it afterwards?
Yes.
Yeah. So all the nails are put in a line, and then you look at all those lines, the tape you saw in those pictures. That's where all the nails were.
Okay, great. Okay, I think that's it. I'm going to turn it back over to Chris Ballard.
Thank you, Sarah. Thanks for those really good questions and really good answers. And I'm delighted that the builder is here on this presentation to answer some of those questions that that folks have. Moving along, and one of the questions that I loved the most was around training and trades and whatever. And I said earlier, one of the big things that we do at Passive House is train people in how to build to Passive House. And the beauty is, if you've got some training in Passive House, you can build to any any level of high performance building. So I just wanted to remind you that we're here to support industry and government in this transition to high performance zero emission buildings. And that if you become a member of Passive House Canada, there's discounts and certification courses and webinars and all sorts of things that you can do to stay up to date with where the high performance building industry is going in Canada. And it is changing rapidly. As Oscar mentioned earlier, there is a marketplace transformation that's happening now as more products, more Canadian-made products are coming online, and it's really important to stay up on those. Few courses we've got coming up. If you're more interested in Passive House, we have our Introduction to Passive House Performance Building. That course starts June the 1st. Everything, of course, is online, and we have live instructors. We have a Pathways to Certification trade certification. The interesting thing is our trade certification, it's about a 3-day course. Well, it is a 3-day course. So, understanding the fundamentals of Passive House and how to work on a Passive House project is just a 3-day program. It's not terribly intense and really helps tradespeople be prepared to work on a Passive House building, so they know not to drill through any exterior walls without permission, etc. All sorts of good stuff there. And then, of course, we have our designer consultant certification, the 120p course. We have a course beginning June the 7th, and that leads to certification. So I'm going to leave it there and thank everybody and thank Parks Canada and Garth for your help and the leadership that Parks Canada brings to this project. We're really excited to learn more. We've got a few more of these seminars to go. If you registered for this one, we'll make sure you learn about the upcoming ones. All of them focused on building in a northern climate. We want to make sure that the businesses and the people in this in the Nipigon region have a good opportunity to work on this project because it is a really significant project. So we're here to support business and individuals in the area to make sure they're ready to work on this project. So I'll leave it there for today. Thank you all. If you want more information about Passive House Canada, please visit us at passivehousecanada.com. We'll also be putting this session on our YouTube channel if you want to review it or refer it to someone you know. So thanks again, everyone, and I'll look forward to seeing you all in our next presentation. Bye for now.